Hello everyone. In this video, let's discuss how to remove linked list elements. Given the head of a linked list and an integer val, remove all the nodes of the linked list that has node.val equal to val and return the new node. So here they are saying that they have given a linked list and a value. I need to remove the node which has a value given. So when I go for the example 1, here there are 7 elements in the linked list with 1, 2, 6, 3, 4, 5, 6. And they have given one more variable called val and the value of that particular variable is 6. I need to remove the nodes which are 6. So I need to remove this one and this one. After removing these two nodes, the linked list should have the elements as 1, 2, 3, 4 and 5. So this is what they have given. Let's go for the second example. Here if the linked list is empty, I have to return the empty list. Let's go for the third example. Here the linked list consists of 4 elements and the value is 7. So I have to remove all the elements and I have to return the empty list. Now let's discuss the logic in detail. So here I have taken a linked list which consists of 7 elements. So the head is 1000. So this is the first node, data part and the address part. Then I'll go to next node, data part, address part. So I have 7 elements in my linked list. Now I have to take a variable called val and the value of this particular variable will be 6. I have to remove this node as well as this node. I have to remove these two nodes. Okay. Now let's write the program for this. First I have to create a temporary node. So I'll take list node temp is equal to new list node. So here I'll initialize the value is 0. Okay. The first step what I have to do, I have to create a temporary node. So I'll create a temporary node here. I'll initialize the value as 0 and the address part will be null. And address of this particular node, let's give it as 500. Done. First step over. Now I'm going to take one more object called current. List node current is equal to temp. So whatever the node which I have created as a temporary node, that node's address should be pointed to the current node. So what I'm going to do is I'm going to consider this particular node as current. Done. Now I have created one more node called temp. So this is what we call it as temp. Okay. Great. Now what I'm going to do is this is a temporarily created node. So in the node's address part, I have to store whatever the value we have stored in here. So what I'm going to do is in temp.next, I'm going to store the head value. Okay, because I'm going to start my iteration from this node, right? So if I want to go to the first node address is stored in head. So I'm going to take the value from head, that is 1000. Where am I going to store? Temp.next. Temp is pointing to 500. Temp.next is this place. Here I will be storing the value called 1000. Okay. Great. Now what I'm going to do, I have to start my iteration of the linked list. So for that I have to take a loop while I'm going to give a condition saying that current dot next not equal to null. Because current is not going to point to the first node. Current is pointing to the node which we have created temporarily. That is why I'm giving the condition as current dot next not equal to null. Current dot next will point to the actual first node of the linked list. So I have to check whether that value is not equal to null. So here current is pointing to 500. Current dot next is 1000. 1000 is not equal to null. Yes, condition is true. If the condition is true, now I can check whether I can delete the element or not to delete the element. For that I have to give a condition. So here I have to check whether the node has the value which is equal to the variable val. So for that if current dot next dot val. So current is pointing to 500, current dot next is 1000. So now I am standing on the node called 1000. In this particular node the value is 1. Whether this is equal to the variable val. So in this case it is not equal. Okay, in this case it is not equal. If it is not equal, what I have to do is I have to go to the else part. I have to go to the else part. So here current dot next is 1000 dot val is 1 equal to 6. No, condition is not true. If the condition is not true, I have to move to the next node. How can I move to the next node? Current equal to current dot next. That's all. So current from this particular node, it go to the address called 1000. How it is moving to 1000? Current dot next is 1000. So current has to point to the node called 1000. Now go for the loop again. Current dot next not equal to null. Current dot next is 2000. 2000 is not equal to null. So I'll go inside the loop. Now I have to check whether this node value is equal to 6. So if current dot next dot val, current is 1000, current dot next is 2000, dot val is 2. 2 equal to 6? No. So I'll go to the else part. I have to go to the next node. So from here I'll move to the next node. Now go to the loop again. Current dot next. Current is 2000. Current dot next is 3000. Okay. Not equal to null? Yes, it is not equal to null. So I'll go to the if condition. I'll check the condition saying that if current dot next to dot val, current dot next is 3000, dot val is 6. 6 equal to the variable val? Yes, it is equal, which means I have to remove this particular node. So if I want to remove this, what I have to do is I have to take that next to node address, that is 4000, and that has to be stored here. So what I'm going to do is in the place current dot next, what am I going to store? Current dot next to dot next. So because I have to remove this particular node, so current dot next is 3000. Okay, current dot next is 3000. So in this particular place, I have to store current dot next 3000, dot next is 4000. Okay, I have to take 4000 and I'll be placing it here. Then go for the next iteration of my loop. Current dot next not equal to null. Check the condition. So here current is 2000, current dot next is 4000. So I'll go to the memory location 4000, that is not equal to null. So what I'm going to do, I have to check the condition. Current dot next to dot val. Current dot next dot val is 3. 3 equal to 6? No. So I'll go to the else part, I'll go to the next node. So current equal to current dot next. Current is pointing to 2000, current dot next is 4000. So I'll go to the memory location 4000. Check the loop again. Current dot next not equal to null. Current is 4000, current dot next is 5000. 5000 is not equal to null? Yes, 5000 is not equal to null. I'll go inside current dot next dot val 4. 4 equal to 6? No. So I'll go to the else part. I'll be moving to the next node. Current equal to current dot next. So from here, I'll move to the next node. Then check the loop again. Current dot next not equal to null. Current dot next is 6000. 6000 not equal to null? Yes, 6000 is not equal to null. So I'll be checking the condition. If current dot next is 6000, dot value is 5. 5 equal to 6? No. So I'll go to the next node. From here, I have to move to the next node. Go to the loop again. Current dot next not equal to null. Current is pointing to 6000. Current dot next is 7000. 7000 not equal to null? Yes, 7000 is not equal to null. I'll go inside the while loop. I'll be checking the if condition. That is current dot next is 7000. Dot val is 6. Equal to the variable 6? Yes, both are equal. If it is equal, what I have to do? In the current dot next, I have to store the next node address, which is not the next node, next node's address. So here current dot next is 7000, dot next is null. So null will be taken and that will be stored in this particular place. Null will be taken and that will be stored in this particular place. Now go for the loop again. Current dot next not equal to null. Current is pointing to 6000, dot next is null. Null not equal to null. Condition becomes false. I'll come out of the while loop. Okay. After coming out of the while loop, what I have to do? I have to return temp dot next. So here temp is pointing to the temporary node, right? So temp dot next is 1000. So that is the first node's address that will be returned. Now when I traverse the linked list, let's see how does it look. First node is 1000. So I'll go to the memory location 1000. I'll take the data. Then I'll go to the next node 2000. I'll take the data 2. Then I'll go to the next node 4000. I'll take the data 3. Then I'll go to the next node 5000. I'll take the data 4. Then I'll go to the next node 6000. I'll take the data 5. Then I'll go to the next node null. That states that I am at the end of the linked list. That's all. This is the logic of the program. Now let's go for the implementation of the program. So what is the first step I have to give? I have to create a temporary node. List node temp is equal to new list node. I have to pass the argument as 0, which means the value of the particular node is 0. Next, what I have to do? I have to take one more object called current. The newly created temporary node address will be pointed to the object called current. Now, temp.next is equal to head. First node address will be taken, that will be stored in the temporary node's address part. Now I will take a loop to iterate, that is current.next not equal to null. If the condition is true, I have to check whether I have to remove that particular node or not to remove. For that, if current.next.val equal to value. If this condition is true, what I have to do? Current.next is equal to current.next.next. Next nodes will be taken and that will be placed. Else current equal to current.next. That's all. Finally, I have to return the temp.next because I have created the node as temporary. So that node's address part has to be returned. That will be pointing to the first node's address. That's all. Let's run the code now. Pass the test cases. Let's submit the code. Yes, it was all the test cases. That's all.